This blaster is sort of a parts recycling project from a failed PCSR and an ESLT catch down here. It wound up being sort of a new design, and I never really figured out a name for it, so for now we're just going to call it Fred. Fred is a pump-action, spring-powered blaster fed by this RSIB. It's also sort of a bullpup in a somewhat dysfunctional way. For those not familiar with the RSCB, or RSIB as I call it, it relies on having a loose tube to hold your darts and a tighter tube to serve as the barrel. In the loose tube, when you tilt the blaster down, the darts will fall down until they get to the barrel, which is too tight for the darts to fall through. However, it's still loose enough that when you fire the blaster, it can blast the dart through this tight barrel with air pressure. RSIBs are more flexible than hoppers when it comes to the different darts they can use. Usually full-length darts are not a problem, even though they take up more space in the magazine. And also, the style of the dart tip is much less important because the tip doesn't have to drag across plastic in order to feed. This blaster also has a push-through end cap. Most of my push-through end caps are a little unusual in that the seal is actually provided by the last dart in, which is just in a tight hole in the end cap. The flap is very easy to push out of the way as you're inserting a dart. The placement of the push-through end cap is reasonably nice for loading from a pouch. Even though you're not quite in the firing position, the blaster can be in a completely ready-to-fire condition while you're doing this, because you don't have to take out the magazine. So, although your finger's not on the trigger, it's pretty easy to drop the dart that you're loading and just jump into a firing position. Using this duct tape to retain this pump grip looks very janky, but it actually makes the blaster a lot quieter, tougher, and easier to build. Normally, the pump grip would be guided and retained by machined slots on the plunger tube, or whatever the frame of the blaster is where the pump grip goes. Machining slots and tubes is rather difficult to do nicely, and it's much more difficult to clean up those slots so that they're not covered in burrs afterwards. Although there have been a number of so-called slotless pump-action blasters, so far as I know, this is the first slotless pump-action blaster to actually not require slots. I'm not really sure why the other ones are called slotless designs, but they require machined slots. So to take apart this blaster, or at least to take the insides out of it, first want to prime the blaster, and then just cut this duct tape right here. Once you do that, the whole pump grip assembly comes off. To get the rest of the internals out, just point the blaster where you want your internals to go and pull the trigger. With the insides out, we can now see a little bit more about this blaster. First thing to note is that the spring only goes back to about here. Now I've got a bolt installed here to act as the spring rest, and the reason I'm using a bolt there is so that way if I want more or less spring pre-compression, just drill another hole, move the bolt forward for more power, backward for less power. If I go for much less power than this, I would have to remove this in order to put the bolt on, but it's attached with duct tape, so that wouldn't be a huge deal. Also, you're really not going to want to cut the power much lower than what I have, because as it is, the spring has a little bit of room to rattle around. The plunger head here is not actually attached to anything. It's merely trapped between the spring and the pump grip. This helps because normally there would be a plunger rod going back here and the catch would interface with the plunger rod, and that would require more stuff going on behind where the spring ends. Instead, the plunger head catches here on this ESLT catch. ESLT uses a double lever design, and so this second piece, which I'm not really showing the inside, it's got kind of a tooth that as you pull the trigger here, the tooth goes down like this. And of course, when the tooth goes down, which would be caught on this part of the plunger head here, that clears space for this to fly forward under the spring tension. I didn't really take advantage of that space saving here. As you can see, I just have this empty stock area here. Also sort of noteworthy is this is an Aeromech PCSR stock, but I'm not actually using any of the functionality. It's just a decorative and ergonomic piece. In the PCSR, this actually acts as the catch block. I couldn't make the catch work, at least not with my plunger head. Although the catch would very readily catch on the plunger head, I couldn't make it uncatch. And that's kind of a problem, because at some point you do want to fire your blaster. In any case, I'd already printed the part, so I used it on this blaster. Towards the front of the blaster, attached to the pump grip assembly, there is this long 3D printed plastic. It's actually hollow on the inside, although it's sealed up, so that doesn't matter. But in any case, this tube doesn't really do anything. It's meant to be a fairly close fit for the inner diameter here, but it doesn't actually seal. That's what this skirt up here is for. Now, the reason I have the seal all the way over here and not over here is because there is a hole in the plunger tube where the air comes out. And if I put the seal at the front, then the seal has to drag back and forth across that hole every time you prime or fire the blaster. I was afraid that would wear out the seal. This is one of a few places where I'm thinking in the future I might simplify things to shorten the blaster and just make it a little easier to build as well. The actual grip part of the pump grip is just a piece of 1.5-inch thin wall PVC, which slides nice enough over 1.25-inch PVC. So one of the big things that to me makes this blaster interesting and perhaps a sort of progress compared to PCSR and other similar blasters is that the seal hardware for the pump seal versus the actual plunger head seal are the same size. So there's no special rod seal. You still have to have a seal for the pump grip, so it's not like you have less seals. But you can use the same sort of seal hardware that you're using on the plunger head on the pump grip, and also because you don't need a special rod seal, which would require kind of a downsizing bushing to be inside the blaster, that means it's a lot easier to get the insides of the blaster outside of the blaster. And if you want to replace them with perhaps an alternative spring, maybe a different plunger head, whatever you want. The other thing that I think is cool about this blaster is what I didn't do on the blaster, which is make it short. Right now, it's actually a little bit uncomfortably long, which is kind of ridiculous for a bullpup design. But there's almost 30 centimeters that I could have saved in this design if I were willing to put a little more work into it and not just use recycled parts from my shop. This blaster could have been almost 30 centimeters shorter if I had been willing to put a little more work into it and not just use parts from my garage. I could have saved all of this distance back here in the stock by relocating the trigger forward. Would have been more work. I would have had to have a linkage mechanism between the new handle and where the catch needs to be. But I would have saved that much space back here. And then also in the pump grip, where I talked about how I didn't want to have the seal dragging past the air exit hole, I'm not really sure that's going to be a problem. I don't know. I've never done it before. But in any case, with this blaster design, it's easy enough to take apart that if your seal is going to wear out regularly on the pump grip, it's really not a big deal. So in the future, I might try this without that extra distance that I required to keep the seal from dragging on here. And, I'll just replace or at least check on the O-ring after, every big war that I go to. Between these two things, like I said, I think I can save about 30 centimeters, which would bring this blaster from being an absurdly long blaster for a bullpup and about an average for a pump action Springer, down to average to maybe a little shorter than the average bullpup, and of course much shorter than a pump action Springer in a more conventional layout. So that's all for Fred. I'll let you know if I ever do get around to making a blaster as good as this blaster could have been. As always, like, subscribe, share, and recycle. Or reuse. I don't think I've reduced in this.